So in this session, we will see how we can query the S3 data lake with AWS Athena using Glue Data Catalog. In the previous session, if you remember, I told you that whenever you want to run some ad hoc queries directly on data, which is stored in data lake, what we can do is we can use this service called AWS Athena, and we can run some SQL-like queries, and we can directly access the data which is there in data lake. So in this session, I will walk you through how to achieve that. This is a simple activity, and such simple activities, if you perform by your own, then it will surely increase your confidence on working with cloud. And after that, we can work together and build some more challenging use cases. So let's get started. But before we jump into the hands-on exercise, let's recap some things about AWS Athena. So as you all know, it is a serverless service. That means you don't have to worry about spinning up your clusters. You also don't have to worry about scaling up or scaling down your application according to the load. This will all be managed by AWS. You just have to run your queries. It is an interactive query platform where you query your data, which will be stored in S3 data lake using standard SQL, and it also supports a wide variety of file formats like CSV, JSON, Avro, Parquet, etc. And you just have to pay for the data that you scan in data lake. And again, I would emphasize that your data lake should be optimized before the scanning, just to make sure you don't scan unnecessary data to save cost, right? I mean, if you have bigger data sets, this will definitely help you to save some cost. And it integrates well with AWS Glue Data Catalog and with QuickSight as well for visualization, right? And you can also, and this service will also, every service will actually generate some logs, and those logs can be monitored using AWS CloudWatch. We will also look into the CloudWatch service as well. So now if we talk about the cost model for Athena, it costs you $5 for 1 terabytes of data scanned, and you only pay for the queries that you run. And it only charges you for the bytes that you scan. It does not charge you for DDL statements like create, alter, and drop. It also does not charge you for the failed queries, but it does charge you for cancelled queries. Let's suppose you cancel the query after 10 seconds, then it will charge you for the data that you must have scanned in those 10 seconds, which is quite obvious. So how to save cost? So for this, just make sure that you use columnar formats like Parquet or ORC, and try to partition the data in your data lake so that you don't end up scanning unnecessary data. This will help you save a lot of cost. And also make sure that you compress your data as well. There are several compression techniques available like gzip, bzip2, snappy. And also keep in mind that Athena can only query the latest version of the data. Let's suppose you have multiple versions of S3 bucket, then it will query only the latest one, and you cannot query the data in the previous versions, right? And also keep in mind that all the tables that you have are external. Always use external keyword while creating tables in Athena. If you use create table without external keyword, Athena will throw you an error, and you all know what external tables are. If you drop a table in Athena, only the metadata is removed and the data still remains in S3. There's one more thing. You cannot run stored procedures on Amazon Athena. And you have to also specify the output folder in S3, where you will be going to store the output of your queries. And then there is a classic use case, which I've already covered. And so we'll look at this. So this is the classic use case. So let's suppose you have different sources which put data into S3 data lake. Then your data is crawled by AWS Glue Crawler, which will get the schema of your data, and it will store that schema into AWS Glue Data Catalog. And this Glue Crawler can run periodically to scan your data in S3 and can automatically populate the data catalog. And then the data through data catalog can then be accessed by Redshift, or it can also be accessed by Amazon Athena. And then you can quickly build dashboards using QuickSight. Hope that is clear. So now let's jump onto the hands-on exercise. So in this exercise, there are 5 steps, and They are pretty basic steps. So in the first step, we will see how we can create a S3 bucket, and we will upload our data. We'll upload a CSV file, which we will download. And then this step two is we'll create a glue crawler. And then we will look at the logs in CloudWatch. And then step four would be we will create another bucket in S3 to store your data, which will be generated by your Athena queries. And the step five would be the last step where we will start querying our data in Athena on the data which is there in data lake. So let me open the AWS management console. So this is the AWS management console. So to get started, you have to create a free tier account on AWS. That's pretty simple. You all guys can do that easily. So now for the data, what you can do is you can go to this data.gov.in and search for any data set, and you will get the data sets here. All are free of cost. Just download a CSV file from any of the data set. Now we'll go to console. We will search for S3 bucket. What we will create a bucket to store the data. So let's name it soil data input, because we will also be creating output bucket. Then just untick this. For this use case, it's not required. Just acknowledge that. See, there's option of bucket versioning. Currently it is disabled, and let it be disabled for this use case. And then we can simply create bucket. See, your bucket is created. Click on this bucket. Upload your data which you have downloaded. Add files. Your data is uploaded. Click on upload. So your data is uploaded now. Now let's go to Glue service. This is AWS Glue. On the left-hand side, you will see this crawler. Click on this. We will create a Glue crawler. Add a crawler. Just name it soil data crawler. Next. Data stores, repeat crawls. So we'll select crawl all folders only. So crawl all folders again with every subsequent crawl. Crawl new folders only. Only Amazon S3 folders that were added since the last crawl will be crawled. If the schemas are compatible, new partitions will be added. So that's pretty self-understanding. And then crawl change folders identified by Amazon S3 event notification. So whenever there is an event, crawl then, right? So next. So we'll choose the data store. So currently our data store is S3, but it can be, we can select from all these services. No need to specify connection, include a path. So our path is S3 path. Select. Next. Do we want to add another data store? No. So now we have to choose an IAM role. So IAM role is required. It basically allows the crawler to run and access your Amazon S3 data source. So it basically provides access to your S3 data lake. Otherwise, your crawler won't be able to access it if you won't create this IAM role. So we will create an IAM role. Let's name it soil data IAM. And next. So now we have to create a schedule for this crawler. The frequency we can specify either run on demand, hourly, we can pick particular days, monthly, weekly, and all those things. So for our use case, we will do run on demand. Next. Now we will have to create a database. So for this database, I've already created one. So what you can do is you can create a database here and just do a create. So I've already created one database, so I'll not create another one. Just name it soil data database. It's straightforward as well. So this is the database in which your tables will be created. This is the crawler info. Finish. So this is soil data crawler. We'll select this. We'll run this. Parallelly, we can go to CloudWatch as well. Open this. Then click on log groups. And then you can, it's not there as of now because it is still starting. See, you got the AWS Glue crawlers log group. Now, if you go down, this is your crawler name and all those logs generated by your crawler will be placed here. Running start crawl for crawler service. So now it is stopping. Refresh it. Now let's, so writing results to database, soil data database, update in database, finish writing to catalog. Now, if you go to Glue console, you can see database, soil data database, and there is also one table, soil data input. So now let's go to Athena. So choose a database, choose the table name is already there. And also, if you go to settings, you have to specify this path as well. So there is no, so let's create one path in S3 bucket. Create a new bucket. We will name it soil data output. And we will uncheck this. We will acknowledge this, and then we will create this bucket. So bucket is output is created. Now we'll go to Athena. We will browse and we will select this, choose save. We'll go to the Athena editor. Then we will try to run a simple select query. Then just provide the database name, database, and provide the table name, soil data input. Let's run this query. See, you have got your data in Athena. You can also save your queries, save as. You can also create tables from query, or you can also create a view from query. All your recent queries will be displayed in this tab, and you can, and all your saved queries will be in this tab, right? So this was a simple use case that I wanted to demonstrate. Hope you found it easy.